Do you ever stop and think about how a new scientific law is actually born? I'm not talking about just a cool idea, but a truly formalized, rigorous principle, something that could one day literally describe the entire universe. Well, today we're looking at the blueprint for exactly that.
I mean, it's a massive question, right? It's not nearly enough to just have a brilliant insight. You need a structure, a framework that other scientists can actually test, verify, and then build upon. You need a formal recipe for turning a new idea into a potential universal truth.
And that's where our source material for this explainer comes in. It gives us a really fascinating case study. It lays out this formal proposal called the Four Standards of Truth for a super ambitious new framework, the Unified Postmodern Theory, or UPT. And get this isn't just the theory itself, it's the actual rulebook for how the theory has to behave.
So how do you build a law of the universe? Well, here's the proposed blueprint we're going to walk through. First, we'll look at why a new standard is even necessary in the first place. Then, we'll assemble the theory piece by piece, its foundation, its core principle, the proof, and of course, the all-important instruction manual.
Look, before any new idea in physics can even get off the ground, it needs a rock-solid, verifiable structure. You can't just say, hey, it works. You have to define how it works, when it works, and most importantly, how to prove that it works. These four standards, they're designed to provide exactly that level of rigor.
And these are the four building blocks we're going to put together. You know, a great way to think about it is like building a new board game. The axiom, that sets up the game board itself. The law, that describes the main goal of the game. The theorem is the definitive way you prove you've actually won. And the rules, well, that's your user manual, telling you how to play properly. Every single part is absolutely essential.
All right, so every solid theory has to start somewhere, right? It needs a foundation, a set of assumptions that everyone agrees on before you even begin. In this framework, that's called the axiom. And it doesn't prove anything, it just meticulously defines the playing field.
And here he is, the main character of our theory, the foundon. This is the basic fundamental particle or entity of the whole system. The axiom states that every single foundon has its own personal space, its domain of ownership, and that's the space where the rules of our new universe are going to apply.
And this is where that rigor really kicks in. The axiom doesn't just say, imagine a particle in a box. No way. It meticulously defines everything. The exact properties of that space, its specific boundaries, and, this is crucial, it defines the only types of external forces that can mess with it. The theory calls them cutting forces. Think of them as any external poke or prod that can disrupt the system. By defining them so precisely, we can later isolate them. This is all about setting up a perfectly controlled environment.
So, once the game board is all set up, we can introduce the central idea of the theory. This is the law, and it describes a very special, ideal state of being called co-moving. So what in the world is co-moving? Okay, imagine a spinning top in perfect balance, just humming along, moving only according to its own momentum and internal physics. That's the idea here. A system is co-moving when its behavior is generated entirely from within, from its own internal potential, without any of those disruptive cutting forces we just talked about. It's a state of pure, natural, undisturbed harmony.
And here's that difference in action, side by side. On one side, you've got the ideal co-moving state. That's our perfectly balanced spinning top. It's totally undisturbed, driven only by its own physics. Then on the other side, you have a cut state. That's where those external cutting forces are poking it, disrupting that natural harmony. The whole goal of this law is to find a way to identify and prove that pure, undisturbed state exists.
Okay, but it's one thing to describe a state of perfect harmony. How do you prove it's actually happening? You can't just look at it and guess. That is where the theorem comes in. This is the mathematical litmus test.
And this right here is the key. The theorem provides what are called necessary and sufficient conditions. Now that sounds kind of academic, but think of it like a key for a lock. If the key turns, the door must be unlocked. And if the door is unlocked, it's because that specific key was used. It's a perfect two-way street, no ambiguity, no wiggle room.
And here is that mathematical fingerprint. You see that phrase, if and only if? That's what gives this thing all its power. All this formula is really saying is that a system is in that perfect co-moving state if and only if two things are true. One, there are absolutely zero external cutting forces messing with it, and two, all of its motion comes from its own internal energy. If both of those are true, it's co-moving. Period. End of story.
Okay, so we have our playing field, we have our principle, and we have our proof. But, any powerful tool needs a user manual, right? You need to know when it's even appropriate to use this framework. And that's what the fourth and final standard gives us, the rules of application.
This is the practical rubber-meets-the-road checklist. Before a scientist can even think about using this toolkit, they have to answer some really basic questions. Is the space we're studying predictable, or is it totally chaotic? Do the boundaries we've set up actually make physical sense? Are the materials involved behaving the way they're supposed to? This is the safety check that makes sure you're not trying to apply these elegant rules to a situation that's just fundamentally messy or broken.
So now we've got all 4 pieces of the puzzle: the axiom, the law, the theorem, and the rules. Let's just step back for a second and see how they all lock together to form this complete standard for truth.
And here it is, the whole shebang, the complete architecture. You start with the axiom to set up the game board. You introduce the law to define the core principle of play. You use the theorem as the litmus test to verify that principle, and you consult the rules as your user manual to make sure you're applying it all correctly. It's a complete, totally self-contained, logical system.
And this is where the grand ambition of this whole framework really comes into focus. The source text concludes that these 4 standards aren't just for one specific scenario. No, they're designed to be a universal toolkit, something that could be applied to systems from the absolute tiniest quantum particles all the way up to the scale of the entire cosmos, as long as those initial conditions are met.
Which, of course, brings us to the biggest question of all. We've just walked through a perfect, elegant blueprint for a scientific idea. But right now, that's all it is, a blueprint on paper. What does it actually take for these elegant equations to leap off the page and become an accepted truth about how our universe actually works? Well, that is always the ultimate test.